Hello. In this video, we present Woodwork for Inventor in the shop fitters industry. Content overview. The video following topics: project initiation and skeleton modeling, module design in the context of the skeleton, metal constructions, wooden constructions, information output, bill of materials, drawings, CNC programs. Woodwork for Inventor is a plugin designed exclusively for Autodesk Inventor. This software is programmable, and we've harnessed this capability to create Woodwork for Inventor, a program with unique functions tailored for furniture production in various materials. With over 20 years working with Autodesk products, our company, established in 1999, specializes in mechanics. Recognizing the well-developed furniture industry in Lithuania, we leveraged our expertise to provide innovative program management solutions to furniture manufacturers. We discovered that the bare Inventor could have features necessary for the productivity of a furniture design. Now, we have more than 1,000 licenses with customers using our productive design solutions globally, including in America, Poland, Britain, and over 400 companies worldwide utilizing Woodwork for Inventor. Project start and skeleton design. The initial stages involve collecting materials from diverse sources, such as architects' associations and construction companies. The project can start from a napkin sketch or detailed drawings, forming the basis for construction. While clients may wish to move directly from a drawing, the idea stage involves collaborative adjustments. Visualization and concept presentations precede the final implementation of a project. The final implementation of the project requires significant time, resources, and finances. Therefore, before starting production, various concepts, color solutions, and visualizations are presented. Both the client and the designer need not worry, as the initial project idea is just the beginning of further work, still being constructed and adjusted. When planning the use of materials and components, understanding that construction situations can change, we acknowledge the abundance of different information. Hence, practice shows the necessity to build from scratch using all available information. A designer's creative journey starts from information to the final construction. A 3D model is being prepared, on the basis of which documentation, CNC machining, and specifications required for production are created. Our practice answer is skeleton design supported by Autodesk software. Autodesk is a program built with a deep philosophy that extends very complex projects. Skeleton design methodology. In skeleton design, the showcased of simple and clear basic shapes, easily crafted using the academic system. This object can be effortlessly divided as distinguishing components, details, and compound objects. Autodesk Inventor mechanisms facilitate the swift separation of the structure into distinct bodies, enhancing workflow efficiency. From each building block, more detailed created, depicting metal or wood structures. In the final stages, a hierarchy is established, starting with large forms and progressively moving to the smallest while refining the construction. Every alteration in the upper level initiates changes through a structure, relieving the designer of concerns about height adjustments, as everything adapts automatically. The skeleton methodology ensures that bound components change in all parts. Transitioning from the conceptual stage to the final design instills confidence in functionality. Autodesk Inventor supports various construction methods, both top-down skeleton and bottom-up individual details during construction and assembly into sets. This object can be effortlessly divided into. It serves as an efficient means of distributing work across multiple constructors, enabling synchronous teamwork on multiple models with the assurance of completing multiple tasks. This proven method facilitates significant changes. By employing skeleton design, the entire model can undergo neat transformations. The top-down design method allows lower components to hierarchically inherit properties from higher components. For instance, new components, composed of separate bodies, can include any component inside and work within its context. They can also inherit any geometry from the parent component, known as child geometry. Additionally, design elements such as planes, axes, and auxiliary points play a crucial role. They aid in creating geometry when relying on the constructed heavy body surface is insufficient, such as drilling a hole diagonally through surfaces. An auxiliary inclined plane with a point allows for the necessary drilling when no direct support is available. This holistic approach to design elements reveals common axes and empty planes where components are placed. Sketches, like the example of a handle shape dictated by a sketch, demonstrate the construction process. Transmission of various variables, such as glass or panel thickness, is integral. For instance, adjusting the thickness from 18 mm to 19 mm for fiberboard panels. Various heights and widths of constructive profiles are crucial when addressing constructional matters. During construction, constructors devise temporary variables. To efficiently manage and recall these variables, an orderly structure with top-down variables is established, enhancing overall work efficiency. This, in essence, is the essence of skeleton design, and now, let's delve into how such a design is accomplished.